Students online, good morning. So, what is the base dimension in this? Is it 1 and 2 or 1.5 and 2? 1 and 2 because this is the base. So, it is having 2 of the dimensions and that has to be included or excluded based on the question. So, if LSA is there, we have to exclude that dimension 2 times. Or at least one of them is there means we have to include that at least once. So he painted the outside of the cabinet of measure as mentioned. How much surface area did, oh it is the female, okay, did she cover if she painted all except the bottom of the cabinet? So what does it refer to? Is it LSA or is it TSA? How many of you can understand? Except the base, rest all is painted. Okay, wait. How many can understand which formula to be used? Raise your hand, frankly to speak. We learned so much like about LSA, TSA and all. Didn't understand? Very few. No? What is meant by lateral faces? Can you show for your that cuboidal box? Your pouch is having cuboid shape. What is LSA? You didn't understand? No? Why? Any effort from your side will definitely help you to understand what is LSA and what is TSA. Yes? Huh? LSA refers to front, back and the side. In the sense these two and the front and the back. But they have told except the base. So I should I include top? Yes. So LSA plus what? Top. So that top is this only, equivalent to the base. Or TSA minus the base. Online students, any doubt? It is
no, ma'am.
Either TSA minus the base or it is LSA plus the top. Because top and base equal area. Even now you did not get those students who are having doubt. You understood? Clear? Okay. So, area to be painted. We have to write. Dimensions are already given. We need not write it. Area to be painted is equal to LSA plus top area or TSA minus base area. This should be there. Anyone you can use. So I will use this LSA plus top area. LSA is what? Base perimeter into height. Base perimeter, rectangle's perimeter. If you have forgotten, I cannot help you. So it is 2 into L plus B into H. LSA plus LB. So you can use this only. 2 into what is H? 1.5. L plus B. 1. L is 2. B is 1. Then plus L into B. 2 into 1. So all are in meters. So answer expected in which unit? Meter square. But while calculating, be careful. Multiplication only. Addition. Don't confuse. This is 2 into H I did. I can do that, right? So it is how much? 9. This? 3. Better to write this because at a time when we write, if answer only is wrong, then that step also will be considered wrong and will not be getting any mark. So 3 3s are product here. 9 plus 2. So 11 meter square. This is the surface area which has to be painted. Clear? Okay. Online students, any doubt?
No, ma'am.
No. Okay. Now, when we come back to the question.
Ma'am,
Hmm.
actually the downboard we cannot see, ma'am.
Okay, I hope you can calculate yourself, right?
Yes, ma'am.
Yes,
Up
ma'am.
to here, I believe it is visible. This is
Yeah,
3 into
ma'am.
3 and then plus 2. It is there in PDF. So if you have
Ma'am,
written,
in
it will help.
PDF you have written 3 into
Ah,
3.
that is, yeah, some students told me, correct it, okay. Silly error. So next question refers to two different solids. Anyone writing here? I hope you have completed. So there are two shapes. One is a cylinder, another is a cube, square. No? So, however, 2D representation of 3D, it is not proportionate. We simply represent it to give a feel that it is a cube. May not be exactly correct. So you can see the diameter also as 7. This also as 7. I'll read the question. Is this okay? Okay, sorry. Then this is the sixth question I wrote. No, I'll do sixth one first. The figure is for sixth one. No, okay. I'll do sixth one. Then
Yes,
I'll come
ma'am.
back to fifth one. Okay. The question is describe how the two figures are similar and how they are different. Observe carefully. You can see everywhere 777. So its dimensions are appearing same. In the sense, if I try to fill something in that volume or area need not match. Remember that. Now, can you imagine there are two such solids in front of you? If you put one inside the other, whichever, which one will go inside another, or won't they be, are we able to put one inside another? If at all, if possible, in what way we can? Yes, Ishan? Definitely, because you observe this 7 and this 7, it is something like they are matching. So if I try to keep this upon that, if the making is very perfect, it will go and sit there only. Like it will be the edge of the diameter, like ends of the diameter will come and fix here. So something like one Rubik cube is there, upon that somebody has kept a pen stand. Like that it will be. If I try, I can slight small 1 millimeter. If I just reduce this, it will go inside and fit properly. Okay, around that, like this will go inside that. But something is left out. No, this corner some space is left out. This corner some space is left out. So volume also is more for this. Understood? You imagine I am filling both, like using something like sugar or something. This gets filled fast, but this has some extra space. When you insert it, you will come to know that this is corners is left vacant. So there also I can fill it. So if you imagine the thickness, negligible. Like I said no other day, you bring down one dimension to so that almost zero. Imagine that the sides are very very thin. Then it should fit inside. One should go inside another. Very thin material used means it can go inside and fit. Height exactly will be same. So on the top you can see one square and one circle like that. From the top what view will be there? One circle inscribed in a square. Can you understand? One square will be there and exactly fitting circle will be there inside. That's the top view. Now can you imagine what will be the volume? Will be this one will be more, right? LSA also has to be more because more material is used to make the solid. Here less. So let us verify that. They have told that we have to find the LSA. You should know the formula, however. We are directly finding LSA of the solids. How they are different? That is the reason they are different. Their LSA and volume or TSA will differ. That is the reason. Which box has larger lateral surface area? If I name this as box 1, this as box 2, the lateral surface area of box 1 is equal to formula. What was the clue I gave? Perimeter of the base into height. What is perimeter of the base? 2 pi r, not pi r square. So 2 pi r into h. Now properly insert the values. Or I can write it as pi dh. How many understood this?
Yes,
2 r
ma'am.
take left and made it d. The circumference is pi d also, isn't it? Few are at least very clear with the formula. Okay, good. So pi 22 by 7. D, that is the intention. I made it 2r, I made it as d. H, 7. Cancel this. So multiply the 2. 154 square centimeter. So this is the LSA of the box 1. Now the LSA of box 2. This also refers to the same. No, the base perimeter is 4s into s or 4 faces. Surface area is s square. 4 faces 4 times side square. 4 times side is 7 square. So 4 into 49. Here I don't multiply actually. 54s I do. That's how we should be fast. Otherwise, while multiplying 4 into 9, your calculation is wrong, means you will write some nonsense only. So 54s are, then deduct 4. Correct, no? So 196 square centimeter. Here so many things come to my mind when I calculate this. This is the square number. Which root is, what is the root? 14. How did I get, 4 is 2 square. 49 is 7 square. 2 squares root is 2. 7 squares root is 7. So, immediately when we visualize, that thing should come to our mind. Oh, it's a square number. So, I can get the square root like that. Factorization. Mind only. Not writing. Okay. So, what we are writing has some relevance to what we learned before. Squares and square roots. Like that. Isn't it? It is connected. If you imagine, you can dig deeper about this, because this dimension is special. So you can explore, you may get some insightful understandings so that you can extend it. Imagine the like this, if at all, if any dimension is there, how it will be. What is it, how many times, somewhere can you understand, is it, these two, are they related? Can we say how many times? So if it is 10, 10, 10, here also 10, 10, 10. If I calculate the area of both, how many times it comes? Like that, what we say, research happens. It is not that somebody who is like very genius only can do research. Even a small thing which is so curious for you can take you forward. Unless you do it, it is not possible. You have to extend. That is called extended study. Not limiting to only some, thinking beyond. Then you will get something extra. So please try to do that, at least few of you. That is the reason behind explaining the formula so many times. So that it is giving you something which is not just there in the textbook. It is something beyond. Textbook questions, however, you will understand. If I just say something, you will not understand. There is something which is wonderful. I tell at the end. Not today. Later, when I take up this one. Last exercise. So I will come back to question 5. Any doubt you have to speak, online students? Okay. Question 5. I'll read the question. Daniel is painting the walls and ceilings of a cuboidal hall. Imagine this classroom is cuboid. Okay, cuboidal hall with the length, breadth and height. Can you tell me which is the length of this classroom? Okay, from here to here. Correct, no? That corner to this corner. Will it differ if I count that? That is also correct, no? Length only. Okay. It is given as 15 meter. And the breadth is 10 meter. Then 7 meter is where? Height. From that corner to that corner. 7 meter is height. Now he is painting except the floor. Obvious, because floor is already tiled or it is having something else, we never paint unless special case is there. Walls and ceilings. So what now? Now those students who did not understand that question, you must tell me what should be calculated. 1, 2, 3, 4 and the ceilings. LSA plus top. Correct, no? Okay. So which one is L, which one is B? Is it very clear in the question? Okay, they have told length, breadth. So L into B should be deducted from TSA, or 2H into L plus B plus LB should be done. Correct, no? That calculation is very clear. Then next part of the question, it's not that confusing. Read it again. From each can of paint, 100 meter square area can be painted. Normally when painters come, no, they calculate the area, how much to be painted. Rough area. We know what area is to be painted and he knows what area can be painted in one tin. So what he will do? He has to, is it multiplication or division? Division. Because he knows that if I use one tin, 100 meter square area will be covered. But if I say 500 meter square area to be painted, it is his understanding that he has to bring 5 tins or 5 whatever containers, paint containers, right? Clear? Any doubt? Okay. So we'll proceed to 5th question. I am not drawing any figure. I hope you can directions, it is dimensions are given, so we can use the formula directly. The area to be painted, don't write LSA plus this and all. You are calculating what should be connected to the question. So area to be painted is equal to the LSA of the room. They mentioned room, no? Okay. Plus ceilings. Ceiling area. So LSA of the room is 2H into L plus B plus LB. 2 into, directly inserting HL, all that values. 7 meter is height, no? L plus B, 15 plus 10. 15 into 10. Don't change the sign, this is into. Even when we use pi r square in that LSA formula, many do that mistake because we are not that familiar with area coming there and sitting, because we are closing with one lid, lid has area, even in cylinder, remember. So 14 into 25. Yes, correct. Yeah, this is common, no? I can do that. Okay, but many will not understand. This is direct, whatever calculation, proceeding to the next step. 25 into 14, 25 for the 100. One in mind, and this has to be added. Correct now? No, sorry. 25 for the 100, 10 carried, 25 plus 10, 35. Yeah, plus 150. So we get 500 square meter. The number of, what they mentioned as cans of paint. Paint cans also we can say, isn't it? Paint cans. Needed to paint 100 square meter is equal to 1 container. Therefore, the number of needed to paint 500 square meter is equal to 500 divided by 100, 5 containers. Yeah, 5 cans. That's how the answer is obtained. But if the method is correct also, often this dealing with the numbers, transposing, I can see many such silly errors. That is telling that they like previous transposing. Even one of the very good student that this calculation of amount is there, no, p into 1 plus deducted when that by is there, a by p calculation of n deducted. How many times I repeated, I remember when to transpose, when to cross multiply. If this is not clear, every calculation further will be like this and you will not be able to score anything, because 4-mark question, first step only something is wrong, because we are changing this p to LHS means this is something into another, no. So it is something like 12 is equal to 4 into 3. So if I am changing this, can I write 12 minus 4? If something is not true for numbers, how can it be true for some big formula and some big entities? So if you understand numbers and dealing with numbers, like how should we change, how should we change the side, and then how that sign changes. So everything stands on integer, rational number, fractions, algebra. And however geometry, this one is entirely geometry in future. Entire mathematics is dealing with basics. So it goes back to, so you should be very much thankful if something is learnt very well in lower classes. Because anything which is not learnt properly will become very costly in higher classes. That time you can't actually afford to like learn also. You don't have time in hand. Applications are high, but you are simply struggling here with the lower concepts. Try to put effort for that at least after the exam, because once that is stabilized, you know now e-resources are there. Even the CBSE has published a few safe educational platform is there. CBSE officially, some video is there. You can download, right? Jigsaw platform, right? It has certain videos. Watch, no, at least something. Or if parents are there, you can also search any educational video on maybe LSA, TSA, and whatever, like dealing with rational numbers, everything. That explains so nicely with some illustrations. Individually, we cannot teach. Where do we help you? If you cannot understand, we cannot actually do for 36 students any justice. It should be done from first standard. Okay, moving to question number 7. Let me read the question. A closed cylindrical tank. Okay, closed cylindrical tank. Let me draw that. How do I depict closed? Okay, I can shade it somewhere. It is closed cylindrical tank of radius 7 meter and height 3 meter. So it is closed fully, base also. This is 3, radius is 7, that's how it is marked. Height 3 is made from a sheet of metal. How much sheet of metal is required? How much refers to what? See, you are making a cylinder yourself by rolling a paper.
We can roll it. We need not need a solid.
If I roll this like this is the material needed to make it. Of course, I should close it. Correct? No. So this is actually, see, circumference is here. Height of the cylinder is nothing but the width. So circumference is 2 pi r. This is height. So area of this only is like LSA. Then I should add the two whatever. In that again radius comes. This radius pi r square. 1 pi r square, another pi r square. So that is how it is. So material used means it is referring to LSA. Clear? If I said other day, if the child is making a cylinder using the clay, It is not LSA, it is volume, not TS,
Volume.
it's volume. Because like how we roll chapatis, so if it is making rolls, not hollow, filled, clay will be filled, no. Child has to make one roll means it will roll the clay and it will make one biscuit kind of appearance. Clear? Then it will be volume. So you have to see the question before you decide whether it is LSA, TSA or volume. Now it is very clear, metal sheet. Sometimes wax is used. Wax is hot wax being poured to the, what do you say, this impressions, like how, mold, correct, exact word, mold. So if there is mold, cylinders mold and hot wax being poured, and that how much of the wax is needed, that refers to volume, not TSA. It is not TSA because entire wax is used up to fill that mold and this, it is filled, it's not hollow. So then also volume. So such questions are there in Oxford or Longman Active. You can refer to at least one or two. Sometimes they give us, there was a cube. Okay, it is now wax is melted and it is now reframed into cylinder. Then how do you decide what has to be calculated? It is reframed. There was one ice cube, cube shaped only. Then the child is putting it into one cylindrical dabba and it wants that ice in that shape. So then volume of that will be volume of this. Understood? Then you have to find like what is the radius, because volume is known. What is the radius of the cylinder? That kind of working is needed. So there something more is there. So try such questions. It will be very interesting. Only exam performance all that you leave, because preparing oneself for something like application is a tough job but not impossible. It is possible provided you decide. So this cylinder we are calculating now TSA because they said metal sheet. So TSA of the metal sheet is actually the material needed, area of the material needed. We can write in this is the area of the material. So TSA we are calculating using formula. Remember 2 into LB, sorry, that is cuboid. Cylinder area, base area, or sorry, wait. We can get that formula 2 by RH plus, this is what? LSA. LSA right now, added to 2 more circular areas, 2 pi r square. So we can get the formula for easy calculation. 2 pi r taken out. Here also 1 r is taken out. So I take out 2 pi r plus h. See, I didn't remember the formula, but immediately we can arrive at the formula ourselves. So now insert the values. 2 into pi value, okay, pi value 22 by 7, r is marked here 7. Then 7 plus 3. Check whether all units are same. Units are same, no? 7 and 3. Okay. Voltmeter. So we may get this as 7 and 7 cancels. 44 into 10. 440 square meter. This much of the metal sheet is needed. Only that is the question. How much of the metal sheet is required? Any doubt, online students? Are you there? Or taking a small break? Students online, speak. Students, are you there online? Vijayta?
Yes, ma'am.
Okay. Sneha is there.
Yes, ma'am.
Okay.
Yes, ma'am.
Any doubt in this question?
No, ma'am.
Okay, no. I'll proceed. Then eighth question. I'll just elaborate. If not completed, at least we can start. When we studied, no, our teachers used to just elaborate and give the work to us. Just elaborate. We used to note down what has to be done, not exactly solving. So solving is done by us, and he or she, they used to tell, like, this is how it has to be solved, and the steps. Next day, we can come up with our method and tell. If not like this, can I solve like this? We used to ask, and there used to be discussion going on whether this can be done. If not done like this, or what are the errors in that particular sum. So only like notes was not very perfect, but the working everywhere was there. Somewhere like one this calculation and then what has to be done. And finally we used to understand, okay, this is how answer has to be presented. And very common mistakes also he always used to tell, this is the very common error, and that is due to what kind of thinking. Students, if they think like this, it is this kind of mistake coming in, like solving. So need to focus on that. Eighth question. The lateral surface area of a hollow cylinder is given. Hollow cylinder. Like somebody has rolled the paper, no top, no base. Or base is there, let me see. If it is cut along its height and formed a rectangular sheet. Okay, very nice. The same whatever I showed just now. So, the lateral surface area of the hollow cylinder refers to the area of the paper. Correct now? Because I cannot fold this like this. Okay, like this also if you want, normally length is like this. Okay, this kind of folding. Then 2 pi r is this. This became circle now when I folded. So it is rolled, not just folded. It is rolled into make a cylinder, and the area of this is known. So if this is the paper, the area of this is given, which is actually they gave LSA of the hollow cylinder, but that is the area of the paper also. Correct? No, they made hollow cylinder using this only. So LSA is 4224 square centimeter or meter. What is it? Centimeter, no? Okay, it is cut along the height. Why did they mention that? So cut along the height. Correct? No? If this was ready already, I started from this and then made it to show you that paper can be rolled. But if this was already there, if I cut along the height is cut. And I opened it to get a rectangular sheet. So this height is given. What they gave it as? Sorry, width. Width is given means what? Height, no? Correct, no? 33. This is width or breadth. Correct, no? Online students, any doubt? We can calculate this, no? 2 pi r or length. 2 pi r, why did I say 2 pi r? Because it is circumference or length of the paper. Because circumference only becomes the length of the paper. Correct, no? Clear? Okay, did I give the figure in that PDF? No. You copied, no? No. Okay. So H is 33 centimeter. Yeah. So how do we find the perimeter of the rectangular sheet? First question we started area, perimeter, same. We have to find the yes. Yes, Ishita.
Now we have to use the area and we have to put the length as the x and we have to cross multiply.
Yeah, then we will get length. When I calculate length, I get 2 pi r. Correct, no? Clear? Then I can find the perimeter. What's the perimeter? L plus B plus B, or 2 into L plus B. Correct now? Try it in rough. You only try. Take a pencil and try. Online students also can try. Fast. So this LSA divided by 33. LSA is formula 2 into L plus B. Sorry, LSA is given. Sorry, 4224 divided by 33. How much we get? 128. Okay, 128 centimeter. This is 2 by R also. It is length of the paper also. Clear, no? So this is 2 pi r also, length of the paper also. So you got length of the paper, find the perimeter. Yeah. So 2 into L plus B is perimeter. This gives 2 into 128 plus 33.
161.
Okay, is that the answer given?
No, 3.
Answer is given different. Okay, I don't know how much ever. Find out. Okay, what this comes as? 161. Yeah. So 300. Yeah. Anyone having any doubt? Now, today you just work on the same question and find out if volume, like whether you can find out the volume of this cylinder in case this is the dimension given. How do you find out? I want R. How do you find R? For finding volume we need R, no? H is what? This one. R. 2 by R is known. So you can find R, no? So you can find R and H is there. Find the volume. Pi R square H is volume. Try to work on that. Need not be in notebook, but you can try, like you will get some idea how, if a question is like this, how to get the volume. Clear? Also solved example 4 and 5. I don't know whether I mentioned in the previous class. 1, 2, 3 we had finished. Solved example 4 and 5 if you have done, proceed to one more.
Example, we should write the notes.
Study. No need to write, just to study. While studying, no, you can use some for practice book for calculations, but you should understand how it is solved in the textbook.